polygons. All right, so hopefully you all remember polygons are really any shape with 3 or more sides. You can't create a shape with just 2 lines. That's just an angle. Always need at least 3 sides to make a polygon. All right, so we did a little bit of dilation before the break, or whatever you want to call it. So I'm just going to quickly review how we dilate shapes. So dilate triangle FGH using center C and a scale factor of 3. All right, so if C is my center, that means that I want to draw 3 lines of projection for each vertex there is in the shape I'm dilating. So a line of projection just takes us from the center of dilation through the vertex that is being dilated. So I'm going to extend that indefinitely because I don't know exactly how much bigger it's going to look like when I dilate it 3 times. So I'm giving myself a little bit of room here, probably way more room than I actually need, but you can never have too much room. All right, so again, try this on your own if you think you can do it, but if not, just follow along. All right, so I'm going to center on C and match up with point G, just like that. All right, now that would be a dilation of times 1. So if I move it up to G and then mark off that distance, that would be a dilation of times 2. And up here, that would be a dilation of times 3. So what I always do, just to make sure it's obvious, times 1, times 2, times 3. I'm going to label that G prime. All right. Then we do the same thing for every single other vertex that's being dilated. C to F. Oh, yeah, that was not perfect, so I'm going to erase that. Redraw my line of projection. I got plenty of time to do this, right? Nothing really going on today. I don't know about you guys. Maybe you have lots of stuff going on. I don't. So hidden on F. All right, that's 2 times. Right, and that's 3 times. Times 1, times 2, times 3, F prime. All right, and lastly, H. All right, this line actually, you know what? I knew when I drew this that it wasn't right. Okay, let's get this. You know what? Either do it right or don't do it at all. That's what I always say. I don't always say that, but all right. 1 time. Was that perfect? That looked pretty good, right? Yeah, that's good. 1 time. 2 times. And 3 times. So I'm going to mark that off. Times 1, times 2, times 3. All right, that'll be H prime. Now we're just connecting the dots like we're got the kiddie menu at our favorite restaurant. Okay. Perfect. All right. So now on the outside, I've got my triangle that's been dilated 3 times, and it's very obvious by the way I've marked it up that that is a dilation of times 3. Great. All right, we are going to skip 3.2 because it's really like a collaborative assignment, and I'm not really sure how we're going to do stuff like that right now. All right, so let's try Are You Ready for More? Okay, so what I want you to do is to really pause the video and try it on your own. Then unpause it, see how I do it, make sure it's the same as you. But really, because of this situation we're in, you really, really need to be trying these things on your own. All right, so pause the video now. All right, great. Hopefully you all started off by drawing your lines of projection. So starting at center C, I'm gonna go through, ooh, that wasn't pretty, but I don't really need it. Going through each one of my vertices. Okay. And of course, if you don't have a printer at home, oh, I probably should have said this earlier. Sorry. If you don't have a printer at home, you can just redraw the triangle. It doesn't matter if it's exactly perfect, but it just needs to sort of look like it. And I'll actually show in a little bit how I'm going to redraw it as well. Okay, so I'm doing first a dilation of 1/2. So A dilation of 1/2 is not going to make this triangle bigger, it's going to make it smaller. Anytime my scale factor is less than 1, I'm always going to get a smaller resulting shape. So in order to do that, this dilation, this is, 1 times right here, half is going to be right in the middle. So of course we use our favorite construction anytime we're trying to find the middle of something, and that is our perpendicular bisector. All right, so I'm making an arc above and below. The line I'm bisecting from both sides, making sure I went a little bit more than halfway. Oh, damn. It's all good. Okay, great. I'm lining up my 2 points, or as my period 3 class knows them as, Jordan marks, because Jordan Russell was like, hey, Mr. Benak, you should always make the points very obvious. And he's right. He is 100% right. That's why we named them after Jordan. All right, so right here, that's halfway. I'm going to call that C prime. All right, oh, not C prime, oops, F prime. C is my center of dilation, so that's not going to be moving at all. All right, F prime. Okay, great. And I'm going to do that with my other 2 vertices as well. Obviously, this is very small, so maybe if you don't have a printer, you're actually at an advantage here because you can draw the triangle as large as you want, and then you don't get sort of all these arcs and lines getting in each other's way. But if you're neat, it's really not that bad. And look how neat I am. That was a joke. It's funny. I bet you're all just dying laughing. At home, please remember to like, subscribe, share, whatever you want. Promote it. I've already put about $3,000 of my own dollars into this YouTube channel just for promotional purposes. I will pay you to promote it. So if you have like a super popular social media account that you get a lot of viewership, if you want to talk brass tacks, I'm willing to throw a lot of money to get this channel up and running. Okay, so it's my last perpendicular bisector, very, very small. So actually maybe this would have been a lot easier if I had made it bigger, but hey, who knows what they're going to give you on the Regents. If we have a Regents exam, who knows? All right, great. So I have now found the new vertices to really cut that triangle in half almost. Well, not really cut in half. That would be like if we drew like a perpendicular bisector for each of the angles, but all right. There we go. So that's very small, kind of hard to see. Now we're also going to do a dilation of scale factor.